Let's jump right in. Welcome to this explainer. As a marine biologist, I spent my life studying the extremes of planet Earth. And today, we're opening up my field logs to literally dive straight in to the astonishing evolutionary biology of deep-sea specimens.
Get this, 80%. That is the staggering estimate of how much of our ocean remains completely unexplored. We're talking about a vast, pitch-black frontier, and hiding in these unmapped depths are creatures that, honestly, might look like terrifying alien monsters at first glance. But as you'll see today, they're actually spectacular marvels of natural adaptation. So, our specimen logbook today is divided into 5 distinct evolutionary case studies: descending into the abyss, ancient relics and giants, bioluminescence and optical adaptations, extreme jaws and appetites, and finally, the unexplored deep frontier. Let's get to it. Part 1. Descending into the abyss. We're entering the extreme environment of the deep sea.
Moving on to Part 2, Ancient Relics and Giants, where we'll explore survival through size and time. Imagine descending thousands of feet into a hostile alien world. The sunlight entirely vanishes, temperatures plummet to near freezing, and the pressure? It's absolutely crushing. To survive all that, life has to adapt in some pretty extraordinary ways. Take the frilled shark, for example. 80 million years, that's how long the species has existed in these depths. It's a true morphological marvel that's kept a highly primitive eel-like body. And when it hunts, it lunges forward just like a snake, catching prey in a terrifying jaw packed with over 300 needle-like teeth arranged in multiple rows. No way you're escaping that.
Because it still so closely resembles its ancient ancestors, this incredible longevity is exactly why the frilled shark is often referred to in our field as a living fossil. For marine biologists like us, it acts as this profoundly beautiful biological time capsule of our planet's distant past.
Now, size is another extreme adaptation down here. 12 feet. Can you picture that? That is the alien-like leg span of the Japanese spider crab, holding the record as the largest arthropod on Earth. It crawls across the ocean floor scavenging for food, and astoundingly, some of these guys can live for over a century. This perfectly illustrates deep-sea gigantism. Basically, freezing temperatures and incredibly scarce food actually drive some species to grow massively just to maximize their metabolic efficiency. We see this in the heavily armored giant isopod. It grows up to 20 inches long, so imagine a massive relative of the garden pillbug, and it can scavenge and survive for years without a single meal. Insane, right? Then there's the legendary giant squid. Growing up to 43 feet long, this creature has enormous eyes built strictly to detect subtle movements in near-total darkness. It's so incredibly elusive that for centuries, rare encounters sparked sailor legends of massive, ship-attacking sea monsters. All right, Part 3. Bioluminescence and optical adaptations. This is all about seeing and being seen in the pitch dark.
Let's look at Vampiroteuthis infernalis, the vampire squid. First off, we need to separate the frightening myth from the biological reality. Despite the red eyes, the dark coloring, and that terrifying vampire of the deep nickname, the myth that it drinks blood is entirely false. Actually, the reality is far more fascinating. When threatened, this little guy literally turns itself inside out, revealing a defensive, cloak-like structure totally lined with spines.
It also relies on photophores, which are specialized glowing organs used to emit light. By flashing these organs, the squid creates a dazzling, confusing decoy in the pitch-black water, which lets it slip away from predators completely unseen. It's like an underwater smoke bomb. Now, the barrel-eye fish takes optical adaptation to a completely surreal extreme. It has a fluid-filled, totally transparent head dome. Through this clear shield, its highly specialized eyes can actually rotate inside its skull. This allows the fish to look directly upward to spot the silhouettes of its prey, all while staying virtually invisible in the darkness from any predators lurking below. Talk about a built-in advantage. Moving from defense to offense, we have bioluminescence, the biochemical production of light. As a predator, the tiny but deadly dragonfish uses this as an active adaptation to draw smaller sea creatures straight into its enormous, jagged teeth. Teeth so large, you guys, they don't even fit inside its mouth. But the absolute iconic master of this tactic is the anglerfish. It executes a flawless 3-step biological ambush. First, it deploys a glowing lure right above its head, brilliantly powered by a symbiotic relationship with bioluminescent bacteria. Second, it just waits in the dark to attract an unsuspecting fish. And third, the exact moment the prey approaches that light,
Bam! The anglerfish strikes with incredible speed and razor-sharp teeth.
That brings us to part 4, extreme jaws and appetites, where it's all about maximizing scarce meals.
Enter the pink-skinned Goblin Shark, which is another fascinating living fossil of the deep. It possesses this horrifyingly effective hunting biomechanism. First, it senses prey approaching in the gloom. Second, it literally unhinges and launches its jaws forward, detached from its skull, using elastic ligaments at incredible speed. And third, it snatches the victim before it has any chance to react, let alone escape.
To secure a rare meal down there, these fish have evolved some staggering anatomical extremes. Take a look at these 3 specimens. The fang-toothed fish boasts the largest relative teeth of any known marine species. They are so big, it actually has special pockets inside the roof of its mouth just so it can close it. Then we have the gulper eel, which has an enormous jaw relative to its body, plus a glowing tail to lure prey right in. And finally, the black swallower. This fish has extreme stomach capacity, allowing it to dramatically stretch and swallow prey much, much larger than its own body.
And finally, part 5, the unexplored deep frontier, the abyss, awaits.
You see, in the deep sea, survival is a high-stakes biological gamble. The crushing depths force evolution to its absolute limits, and sometimes with fatal consequences. We actually frequently find black swallowers floating dead at the ocean's surface. They become victims of their own success after trying to consume and digest a meal that was simply way too large.
With massive expanses of the deep ocean still completely unexplored by humans, we're left with an exhilarating final thought. As we continue exploring the abyss, who knows what other monsters, what other spectacular, monstrous biological adaptations are just waiting to be discovered in the dark. Thank you so much for joining me on this field review. Keep questioning, keep exploring, and I'll catch you in the next explainer.